If you are using an open source search engine for full text that isn't Solr, you should switch to Solr, but I'm not going to convince you today. There are a lot of reasons for that, and we've seen some of the largest deployments in the world go from Solr to Elasticsearch, it was hot, and then back to Solr. And everybody's asking why. Well, one obvious reason is the Solr Cloud, which sort of addressed a lot of the issues that made it difficult to scale Solr in a cloud environment. But then another reason is the Solr Tagger, which is new as of 7.3 or 4? 7.4. So let's talk about the Tagger and how it's so much more than search. So,
yeah.
I'm Marcus Eagan, clearly. And
I'm Erik Hatcher.
And we're going to demo the world's most widely adopted full-text search engine in the world by introducing the Solr Tagger. Solr Tagger allows you to recognize known entities in a low latency manner. Through a demo of the Tagger, we're going to demonstrate how Solr can power chat applications, translators, research tools that aren't necessarily search. So, next slide. And then we'll start with Solr. Solr is a highly scalable, configurable, and powerful search engine, and he wrote a lot of it. He also wrote a lot of the code in Lucene. So you're working with the real master. I'm just getting involved. I hope to extend it in a variety of ways. And currently I'm just arguing in pull requests. I think one of the great capabilities of Solr is replication and shard management. Makes it a very scalable and robust system. That's why you can use a lot of the techniques we're going to demonstrate today at the billions scale, billions of document scale. So the next thing is the Solr response.
Sure, I got it. I get this. Turn that one off now. Okay, so I'm Erik Hatcher. I'm a Lucene Solr committer. I co-authored the book Lucene in Action. And this is the first time to Poland. I'm glad to be here. I've spoken at one other Devoxx, great event. So thanks for having me here. What you see here is simply a screenshot from hitting a Solr endpoint to do a search. And this search is going against, in this particular case, every city in the world that's got a population of 15,000 people or more. And that's about 150,000 cities, I think, in this particular data set that I have. And so I'm doing a search for Krakow here. So this is just out of Solr. I'm just trying to show you an introduction to Solr. So straight up full text search there, faceting as well, faceting on a type of object. So what this is, you can see the URL there, /Solr/things. I've got a collection of things. Things have a type, and Krakow is a city. This is that same request to Solr, except getting JSON back, just to show you that you can use JSON, you can use the UI that's in Solr to browse around for diagnostic purposes, and then you build applications around, of course, this endpoint here to do search results. And this is, in our product, Lucidworks Fusion, doing the same search, just showing the results within the frame of our query workbench in Fusion. So that's the basics of Solr. Probably many of you are familiar with full text search in various ways, generally powered by Lucene. So building upon that, there's a facility in Lucene in Solr called the Solr Tagger. It's a special capability that's unique to Solr. The way that it works is that you build a collection of tags, is what it's called in the Solr Tagger terminology. Basically, you're just indexing standard documents. And I'll show you how it's slightly different in a special way to facilitate the tagger in just a moment. This tagger is known as a naive entity tagger. It's about tagging things that you already know, but it's tagging a lot of them. So if you have a giant full-text document and you want to find all of the cities that you know of in that full-text document, you can send that text to the tagger endpoint and get back all of the cities in there and their positions, as well as all of the metadata about those cities. So that's another special aspect of the tagger, where tags aren't just strings, they're actually full-fledged documents with rich fields and metadata associated with them.
This is a really important concept here, is like this naive tagger, and everyone wants to add natural language processing to their search pipelines, or machine learning. They want to automatically generate certain output. It's like, if something is of very high value and you already know about it, the system should as well. So you can remove the workload of some statistical probability or something that's computationally intensive, and allow the human classification to work for this field, for the tagged field. It's very important that your high value entity is recognized by a human.
And this is, the text here is from that documentation from the Solr Tagger. One of the great things about the Solr Tagger is the contributor who contributed it also made a full-fledged demo. So if you go to that documentation there, you can fire up Solr and just run the couple of commands that's in the documentation, and you'll have the basic cities that I'm showing. I built upon that and expanded on that and added additional metadata, like the type, because I don't just have cities, I have other types of things in my entity collection. So I based it on that, but the demo is superb. Here's an example of hitting the tagger endpoint with some text. This is just using the tool Postman. The top there is the URL to the Solr Tagger endpoint. It's just /tag against your collection. And the text that I'm tagging in this case is Devoxx in Krakow, Poland. And as you can see in the output of the data there, that it returned back that the city Krakow is in offsets 10 to 16. Very basic, kind of obvious that you can do it, but again, there's 150,000 cities in here, so it will tag any of those, all of them that happen to be in the text that you post into the endpoint.
So yeah, if you look at the tags object member here and the JSON object, you'll see that there's pretty gnarly that ID line. That's because you can, if you had Krakow, Poznań, Gdańsk, they'd all show up. And Detroit, Charlottesville, they'd all show up as tags in that array. So very powerful here.
And we'll see that in a minute in a demo where we tag a city name where there's many cities in the world with that same name, and then we can narrow it down by geolocation as well. So tagger basics, this is kind of some underlying configuration capability needed to get the tagger going. You create a collection in Solr, just a general collection, but you augment that with a special field type. This special field type concatenates all of the tokens into a FST-powered, a finite state transducer-powered field in a compact format within the Lucene index. And then the tag request handler is the /tag endpoint. That's not registered in the out-of-the-box Solr configuration, and it requires just a simple post JSON configuration to enable that endpoint. The tagger itself has some switches here. I'm not going to really go into great detail of this, but the idea is that you have some options on how it tags things. You could have, for example, there's a brand of linens called white linen. It's called white linen, so like sheets and drapes and things like that for your home. White is a color and white linen is a brand. If I tag that text and I have both of those entities in there as a color, as a brand, it can either tag just white linen because it's the broadest tag in the textual span there, or it could tag white and white linen and have overlapping tags. So you have some switches to control how the tagging does what it does. Of course, you can limit the number of tags that you do there. And then you can pick which fields you want. In this particular data set I have, I've got many fields. I've got the lat long, the name of the country that the city is in, and name of the state the city is in, and all of the kind of alternate names of the city. So I've got a lot of information about cities, about each city in there, but I may only want a few of those fields back. And finally, one of the very useful capabilities of this tagger is to be able to limit which tags you're going to actually tag on the text that you're posting in there. So if I've got various types of things into my tagger collection, I may only want to just tag cities and not tag colors and brands and other types of people's names and so on. So I can limit that. And I can also limit that by, say, geolocation. So any type of Solr query, I can filter and limit that down. So we'll see an example of that in just a bit. Tagger use cases. So what would you use this thing for? At index time, you may pass your text of the incoming documents through the tagger and grab all of the known things. So if you've got, say, a pile of PDF files that you're indexing and there's city names mentioned in there, you could tag those cities, and then during the indexing pipeline, you grab the cities that were tagged and extract them into another field. That gives you the ability to facet or navigate or narrow down the PDF documents that happen to mention a particular city, for example. So index time is a powerful way to leverage that. Another way is that you could leverage it at query time. And you leverage that query time to improve relevancy or for better query understanding. And you can see the two examples there. And this actually is alluding to the machine learning aspects that you can use behind the scenes there to populate the tagger collection. For example, we have a facility to machine learn misspellings in our query logs. And for example, if folks spell Devoxx with one X, and over time our machine learning jobs learn that Devoxx with one X really should have been Devoxx with two X's, our machine learning job will populate the tagger collection with a tag that just says Devoxx with one X is the tag, and another field in that tagger collection is what it really should be. And then there's a facility in the next stage of the pipeline, of the query pipeline, to do that query replacement. And then the other example here, for better query understanding, someone searches for blue shoes. We have a color field in our apparel catalog, and we extract the color that the user mentioned in their query, and we could filter that. So we only see blue things that match the full text query of just shoes. Or we could boost blue things. So how you use the tag, or the tags that come back from the tagger, is kind of the secret sauce that you add and leverage beyond just simply noting where things are, just being clever about noting where they are, extracting them, and then leveraging them in a different way.
Witamy Wyszczewski. Right here is the Welcome to the Future, for those who don't speak Polish. This is the area where you can extract a lot of value because one of the things that makes conversations between two humans so so fluid and so comprehensible most of the time, if you're speaking the same language, is that you know when an apple refers to an apple and an apple refers to a computer. And so you can add an additional layer of context with the Solr Tagger, which is the heart of understanding, whether it's understanding data, understanding text specifically, or understanding someone else's intentions or a user's intentions, is this layer of context. So the recognizing entities for query understanding can be replaced with recognizing entities for conversation understanding, recognizing entities for purchase understanding, shopper understanding. You know, it doesn't have to be about, oh, I type in the search bar and get this result. It can be, I'm navigating this way because I'm looking for this.
This is a screenshot from our platform, and the point here is to show you how the tagger gets leveraged in conjunction with many machine learning jobs. So we have phrase detection, query, underperforming query rewriting, misspelling, head and tail analysis, that's not shown on there, and synonym detection. All of these jobs are very sophisticated machine learning jobs written by data scientists, and those things feed into the tagger collection. So at the end of these jobs, they simply write to the tagger collection, this piece should be replaced with this piece. But there's a lot of machine learned magic behind that. And this gets leveraged in the query pipeline within our platform to, and you can see, and actually this is a very important point, this is the first stage in our query pipeline. And as it goes through the pipeline, eventually it queries Solr, but the first thing it does is takes the query and tags it. And you have options, so you can see the checkboxes there to turn on and off which types of rewrites you're going to apply. So this is just really just kind of an example of showing you how the tagger gets embedded into bigger systems and then it gets leveraged. Again, it's a very simple facility in terms of the data that you get back, but the cleverness and the power comes from what you do with what comes back from it. Here's just a screenshot of a news article, actually, that shows how important this type of capability is. This is Bank of America. They've written a basic chatbot, so customers can interact with that and say, what's my balance in my savings account? Savings account could be a tag. We know what that is. Now we've recognized that entity in their utterance and able to then augment the query, rewrite the query, and filter it down to the content. We've understood the query in a simplistic manner, and that adds value and power to being able to intelligently interact with a user. All right, so let me just do some demos here. So I've got a chatbot demo, but first I'm going to show you the basic tagger. All right, so this is a simple tagger UI here. I did this demo for our meetup tour that Marcus and I did a couple of months ago, and our final stop was in San Francisco, so I wanted to put something that was San Francisco specific in there, and you can see I've got sushi in San Francisco. I've got all the cities in there. I don't have food types. I could easily have put food types in there and done that, but what I've done is I've tagged cities. And when I tag cities, there's a whole lot of San Franciscos out there, like a lot of San Franciscos, right? So what's this? Argentina and Colombia and so on, right? There's a lot of San Franciscos. It's hard to make sense out of that. How could I make sense out of tagging San Francisco if I get back a ton of them? Well, I'm looking for sushi in San Francisco, but I'm in San Francisco, California. In fact, when I check this checkbox here, what I've done is I've applied a filter, that FQ that you saw in the parameters there, a filter query, to filter geospatially to cities that have a lat long that's within, I think I used 10 kilometers of our headquarters in San Francisco. So the only San Francisco that is within 10 kilometers of San Francisco, California is San Francisco, California. So I click that, and you can see some gory details of what that geo filter looks like. But now I get down to just simply one city. Right now, if I have restaurants and their locations in my system, I can apply that against that collection of restaurants for a successive search in my pipeline there, and narrow down and search for the word sushi in the descriptions of restaurants within, obviously, just San Francisco, California. So that's the tagger. Again, simplistic, but using geospatial filtering and other search capabilities there, I can pull these things together and have a rich, powerful system. And I can do other. If I do Krakow, let's see. Oh, I see. So there's no Charlottesville or Krakow near 10 kilometers. So if I do Krakow, right, it's not tagging any Krakow, but it's because I have that checked, right? So if I uncheck that, then I get this Krakow. All right, makes sense? Everybody with me so far? So the next thing I want to do is show how we've built this into a chatbot type interface. And what I've got here is this thing called Lu, for Lucidworks. And just make it a little bit smaller here. I can say things like, hey Lu, what time is it? And the way this operates is there's a query pipeline that it's actually just one stage in a query pipeline that's got a bunch of JavaScript in it, is the way this particular demo works. That JavaScript makes a request to the tagger collection, tags the query that I just issued, the utterance is what I call it here, then takes those tags, generalizes the utterance based off the type of things that were tagged, and then makes a search request to a separate collection. I called it the grammar collection, that contains phrases and utterances associated with an action. In this particular case, I typed in, what time is it? All I have in my collection are cities. There's no city mentioned in an utterance, but I have a grammar item that's associated with what time is it, and the action is some JavaScript on the client side to display the local time. So in that particular case, not being tagged, I made it kind of easy to click examples over here, so I don't have to type all of these things and you see me make typos. So if I just click on this one, this is just kind of an example to show that I can do some actions here. So what I did is just set a timer alert, so in 5 minutes it's going to pop up in the browser here and say, wrap up this demo. Okay, we saw what time is it. Hey Lou, who are you? Lou from Lucidworks. Hey Lou, where are you? Just put some silly stuff in there. All right. I have also, and this is an interesting one, I have and I'll go ahead and click it so you can see. It doesn't really show anything exciting, but what I did is I said, learn cities. It's already there, I've already done it, but it's re-indexing the cities. So what that did was in fact, the tagger is used in that particular utterance. I have already run behind the scenes a data source that puts into the tagger collection the names of the other data sources that are available. So I've got a data source for cities and for colors and so on. So I can say learn colors, learn cities. And what that does is simply send a request to our platform's jobs endpoint and starts that data source. The way that works is that I've got, in the tagger collection, I've got the word cities in the tagger collection as a separate document, and that has a type of data source. And so, actually, I can kind of show you behind the scenes of what happened there. Let's get this in a better JSON view. Okay, so what I'm showing you is the full JSON that came back from the server back to the client. So I uttered, and I used the parameter u, learn cities. That tagged, this is the tagger output here that I've embedded in the full output of the response. It tagged the word cities and said that it is of ID cities, and that is of type data source. In that JavaScript, once I've gone to the tagger and tagged that utterance and said, well, I found a data source mentioned in this position in the request, the pipeline there replaces the tagged items with their type. So what I've got is learn data source right here. So I've typed the utterance. Now my grammar collection has a single grammar item that says learn data source. It doesn't know about cities, it doesn't know about colors, it doesn't know about any other data sources, it just knows about learn data source as a type of thing. When we look that up, we get a match in the grammar collection, and that returns back and says, well, what you do when somebody says learn data source is you hit the endpoint that says start that data source. And so that's how we tie the tagger, type the utterance, and then go off and look up something from another collection. And then you can kind of see all the gory details behind the scenes there of the grammar item, and the grammar item says learn data source, and that it's got an action associated with it to hit the Fusion API. And then in the browser, it says if I've got this coming back in the response, then what I do is I take I do what it needs to do and hit that endpoint. Okay, so that's that particular utterance. So now we've learned cities, and I've got it so you can click here and you can actually see what that document looks like. It's a very simple document. There's nothing to it other than it says that cities is a data source. So I've got where is Krakow. It does the same thing. It tags that utterance, finds out that Krakow is a city, looks up where is city in the grammar collection, and then the output of that is to display OpenStreetMaps. And so the zoom level is a little low there, but here's our fine city that we're in right now. Some other information I happen to have in that collection is population of the city. It's probably a little bit dated, but there's that. I think I looked it up. Then you see I've already got my 5 minutes. My little timer just said wrap up this demo, but we have 20 more minutes, so I'm not really going to wrap it up. So again, I've tagged the city, and I know that I am looking up what is the population of city in my grammar collection, and the output of that is just to show you the value of the population field from the things collection for that particular document, for that particular city. Likewise, another city, I could put any other city in there. I happen to reside in Charlottesville, Virginia, and you can see much smaller city, but very pretty. Please come visit. Okay, so that's the tagger in essence there in terms of how I'm leveraging it from a chat interface, tagging it for known things, and then looking up a generic version and typing that utterance and looking that up. Does that make sense so far? It's kind of a little Tinker Toy demo that I put together. I've also, had some fun with this thing. Last year, for some reason, I had a manic moment where I had to develop a game. And so I love the game Set, so I actually embedded that in there so I could say, hey Lou, play Set, and it pops this up, right? Do people see sets real quick? Some people see them really quick. My kids can see these things, and bam, they just have a set. I happen to seed this one with the same random number for this demo, so I happen to know where some are, so I can, pick them out there. All right, so that's Lu and what it can do, and how using the tagger in conjunction with whatever cleverness you want to put on there, like typing the utterance, looking it up in a grammar collection from that replacement there, is a very powerful mechanism. And again, we've got thousands, hundreds of thousands of documents. It could be millions, actually, probably even billions, but that's probably on the extreme side of things. But millions of things you can put in this tagger collection, and within milliseconds, you'll have full text documents tagged with all of the entities that you've put into that tagger collection. Okay. That is Lu. And let me just, I've got a screenshot there for that. All right. And this just describes what I just talked through and how it does slotted utterances and finds the associated actions there. And this is describing what I described there. Where is Krakow? It's tagged. And it's got a Latin long and a population. I should have put the population on there, but I'm actually, where is city? So I generalize that query, and then I render the map of the city that was returned. Now, I don't have the smarts in there. If I had said where is San Francisco, it would have just showed me the first San Francisco that it got to. But you would have to deal with that. If you've got many overlapping entities in a particular location in your text, what do? I don't necessarily have the answer for that, but that's a challenge for your applications that are using the tagger. It's going to tag them. You could filter and tag only certain things so that you narrow it down and don't get so much back, or you could tag everything, and then now your client-side facility is going to have to walk through those tags and augment the query or build new fields or whatever it takes to do what you need to do with it.
So, as you think about, okay, I just saw all this cool stuff and it's in this library I once used or I still use, and it's very powerful. How do I leverage this? How do I go from today to implementing features with the Solr Tagger? And I would challenge you to think about what is the most important context-defining interaction that your users have with your applications. So if you're working if you work with a support application, is it the product? If you're working on an airline application, is it the status, like how many miles they've flown? Because whatever field you decide to tag in the Solr tag sense will be available to you to take some actions faster than almost any other mechanism available that I know of on the internet. So I challenge you to think about what defines context in your application. And even if you don't use the Solr Tagger, this is something that we need to think about when we're trying to build personalized and engaging digital experiences. The tagger drops it, it drops it in pretty JSON, or not so pretty JSON until you prettify it, but it drops it in a JSON object and makes it available for you to take actions. So it's a good option. But for everyone building any applications, the context-defining moment, the query, interaction, the action that the user takes is really important because that's going to allow you to understand what they want to do next.
All right, so I just want to give you some pointers to some additional information, and then talk through some more sophisticated things that have been built upon this as well. So One thing to point you to is this blog. I wrote this blog entry after our meetup tour to put out the types of information that we did there, so that's out there. We also have wrapped up that sushi in San Francisco tagging demo there within our Lucidworks Labs system that's hosted on our website, where we have many types of add-ons to our platform in these free instances that we host, and you can just go there and sign up for one of the instances and click go, and you've got an instance of Fusion plus whatever that particular lab adds onto it, and then our Tagger lab is that sushi in San Francisco one that you saw there, with the data and everything all embedded within it, already indexed and already ready to go. So go to that, and all you need is a GitHub account to authenticate through, and you've got the free instance of Fusion that you can use for a day or two. I also want to cover this thing. So a couple of months ago, one of our colleagues, our chief algorithms officer, Trey Granger, did a presentation on natural language search with knowledge graphs. He is one of the contributors of another unique and very special capability of Solr called the semantic knowledge graph, the relatedness function. It's going from one term to another term that's related in the context of a particular set or subset of your documents. And he actually took my little Tagger demo and then he made it look a little bit prettier with colors and so on, and put this nice little diagnostic stuff in the UI there. And in this particular case, he was presenting at a conference called Haystack, which is a great conference in Charlottesville. And his example was BBQ, barbecue, near Haystack. Haystack is in his collection as an event. That event is tied to a venue, which was a really nice movie theater. And that venue, of course, has a geolocation, a particular lat long, and using the connectedness of these documents in a graph-like function can navigate from using the tagger to tagged Haystack, and then uses a graph query, the Solr graph query parser, to navigate from the tagged event, a Haystack, to a location, and that location ends up going through the graph, through a venue, to a location. So very clever capability of Solr is this graph query parser. So he's tying the tagger to the graph query parser, and then also to the semantic knowledge graph. So when someone utters BBQ near Haystack, it tags, he's got near as an operator, and that's a tag itself. He's got Haystack as a tag. Those get pulled out. Now we know a location, and we know BBQ, although BBQ itself may not be rich enough to get the full suite of things that I actually intended to find when I'm looking for barbecue. So navigating the semantic knowledge graph of the collection that you have, which are in this case restaurants, you look up the word BBQ, and the semantic knowledge graph comes back and says, well, BBQ is like ribs, is like brisket, is like pork. And those terms are also are associated with documents of type restaurant. So a lot of rich stuff just happened using the tagger, the graph query parser, and then the semantic knowledge graph. So again, the cleverness that you use to build upon that with the tagger as a front-end preprocessor allows this very rich capability here to, again, to do these really sophisticated things.
And it happened very fast. I mean, sub-second, always. We haven't tested it in the trillions of documents, but it's fast, very fast. So.
And there's a pointer to Trey's presentation. There's a video of him delivering the presentation, so you can see he did a lot about the semantic knowledge graph and a little bit about the graph query parser and a little bit about the tagger, but he was really focused on that semantic knowledge graph, and then again, kind of wrapped up the whole presentation with how tie all of those things together. So that was a pretty powerful presentation for me, myself, to see how he thought about this thing and used the tagger in a very clever way. All right, so let me just have some closing points here. The Solr Tagger provides known entity tagging of text. Sounds mundane, but again, you've got a large amount of things that you already know about in your domain. If you're e-commerce, you know colors, brands, categories, types of products that you have. Right? You have a lot of rich metadata about those things. Those things are what your users are going to type into your search box. You might as well recognize that and leverage that, knowing and doing some good query interpretation there and understanding. The tagger's just built on standard Solr documents. You can use the tagger collection also just for full text search. It's just a regular collection. You just happen to have one special field that is the one that's built with that FST for high performance tagging. And it's very fast, as Marcus has said. What can you use this thing for? Again, use it in the indexing pipeline to augment your documents, kind of a naive classifier or extraction of things into separate fields for better filtering or navigation. And as we've seen with the demos there, it's a great first stage in a query pipeline to understand the entities that you already know about in your domain, and then leverage those for improved relevancy by either boosting by those particular things that you've extracted or filtering to them. Let's see, what else? I also want to point out that the tagger is what it is. It's a tagger of known things. You're going to need to augment this with other techniques. So if you need to recognize dates or numbers or money, those types of things, those aren't things that you're going to have in the tagger collection because they're very dynamic, but they match a particular pattern. So regexes are always your friend. They're going to be a valuable piece to the puzzle as we work through understanding a query as well, or understanding text, right? You're going to need to pull out particular patterned looking things. That's not what the tagger does. Natural language processing certainly is another piece in there. And you know a lot about your users, and you can leverage the query context of where they are, what you know about their past queries or their demographics, and augment the query given the information that you already know.
So, are there any questions about what the tagger could be used for, or does it work in this way, or is it an Elasticsearch? No, it's not. But yeah, go ahead.
Have you considered GraphQL API?
I didn't understand.
GraphQL API, have you considered GraphQL?
Good question, good question. Well, I would say that there is a graph query parser in Solr that if you model your documents as nodes and arcs, it can walk those nodes and arcs. So if you had a GraphQL parser would simply be like kind of syntactic coding on top of generating that graph query parser expression. So kind of already have graph in there, but that's a good point. Should look into that. All right. So let me just say something here while y'all are thinking about questions here. We're out of most people's sizes at our booth, but we have T-shirts that say "You auto-complete me." The reason that we're here in Poland giving this presentation and having and sponsoring this event is we're looking for developers. And
developers.
we need you. We're one of the sponsors, so we can kind of have a little ad here, I guess. But we want developers, and we want smart developers, and I've been told there's super smart developers in Poland.
I'm the one who told him.
And he knows from personal experience, so check us out. Check out Lucidworks, email us, get in touch, send us your information, and yeah, we'd like to take it from there.
You know, nie rozumiemy się mówić po polsku, but we try. And I think that Poland used to be a much larger country. So when we say we're interested in Poland, we're also interested in
the region,
all of what used to be Poland. So Ukraine, part of Ukraine, and
the world, right?
Yeah, Lithuania.
We just happen to be here, so we're myopic on that. But the whole world, of course. But y'all are very special.
Yeah, everyone in the world. But Poland is kind of this area of the world is kind of an epicenter for a lot of scientific discovery and music and culture. And I've never seen somebody turn a pork knuckle into something so tasty, like golonka. I mean, a lot of creativity here as well. So, if there are people who are interested in working at the largest scale, I mean, we deal with companies at the largest scale. We are starting to work with smaller and medium-sized businesses and businesses that aren't huge, but 90% of the global 2,000, the largest 2,000 companies in the world, use solar. So that's the scale we operate at. We're open source at our core, and it's not just solar, it's also Lucene, of course, and Spark, and a number of people in the company are contributors to a host of different projects. Even though everyone here thinks I'm a salesperson, at Poland I also am a contributor to a lot of projects. Mm-hmm. So you all should come work with Lucidworks. And if you're in Warszawa, you might be in our office. But if you're in Wrocław or Krakow, you'd have to open the office. But we're supportive of that because we love everyone, everywhere.
Questions? We have 3 minutes. And while, again, we're looking for questions, yeah. You just repeat the question, Marcus, too, maybe.
Yeah, okay. Let's say that I have this, let's search about the NLP, and you have BB Kill near someplace, and I miss the near. Let's say that I put BB Kill and the name of the place. Can I have some kind of, there is some kind of enhancement or enrichment of the query search that can figure out any possible action missing in the query to infer what should be searched? Don't know if I get it.
Yeah, I'm not sure I fully understood what you said there. What that demo was just a quick and dirty demo to show how those technologies could be put together. Certainly it's not the end of the story there. And should be expanded upon. If you happen to be size extra large or double XL, we have a t-shirt for you at our booth right up there by the food in the corner there. So please join us and help us lighten our load on the way home if you so desire. Thank you very much for your time coming to our talk.